Hi guys, please like, share and subscribe and contact this number if you want lectures related to any CM, CS or CB subjects. Thank you. Okay, so before I get into any questions, I want to discuss with you this very important topic of temporary initial selection. Okay, again super important from exam point of view, and it will be important throughout the subject, right? So let's just talk about what this is. It is about what it says exactly. It is about selection. Now, what is selection in insurance in general, and what is this type of selection that we'll be talking about, which is called as temporary initial selection? Okay. When I say selection in the context of insurance, in very simple terms, and perhaps I'm oversimplifying this because this is not a part of the syllabus anymore. Only temporary initial selection is the only type of selection which is a part of syllabus now. Earlier we used to have other types of selection as well. So let me give you a very simple definition of selection. Selection basically means, or selection is a phenomenon that causes the mortality of two subsets of the population to be different from each other. Okay, selection is a phenomenon that causes the mortality of two subsets of the population to be different from each other. For example, males and females have different mortality. This is gender based selection. Okay, males and females have different mortalities from each other. So this is gender based selection. Another one can be smoker and non-smoker. Okay, that is another example for you. Okay, and there are many other such reasons because of which different subsets of the population have different mortalities, and life insurance companies tend to select these lives differently, that is charge different premiums from them, and probably some life insurance company would not even be willing to give insurance policies to smoker, and same thing applies to health insurance companies as well. Now these selections that I have described to you, these two, they are examples of permanent selections. Smokers and non-smokers will always have their mortality to be different. Smokers will always have a higher mortality. Males and females will have a permanent difference in their mortality. Females will always live longer. This is a permanent selection. What we are now talking about is called as temporary initial selection. Okay, this is a temporary phenomenon. And what is the source of this? The source of this phenomenon is the underwriting. For temporary initial selection, the source is underwriting procedure conducted by the insurance company. What do I mean by this? Whenever an insurance company gets a new policyholder onboarded, whenever they sell a new insurance policy to their policyholder, they conduct a procedure which is called as underwriting. That is basically they try to assess the risk associated with that person based on their age, based on their gender, based on their demographics, based on their lifestyle habits and all of that. All lives are not similarly risky from the point of view of a life or a health insurance company, right? Different risks, different lives pose different risks, right? So as a part of these underwriting procedures, what a company does is a lot of times they make the policyholder fill an underwriting form or go through a health checkup. Okay, and in this underwriting form or in this health checkup, usually what is examined is how is the health of the person, whether they are a smoker or a non-smoker, whether they suffer from any chronic diseases or not, such as cancer, AIDS, other autoimmune disorders. It can be something as simple as type 2 diabetes. Or something like hypertension. And for these cases of policyholder where there are some chronic, comorbidities, these are more risky lives, right? So for these cases, mostly in case of like common diseases like type 2 diabetes and hypertension, which are which are very common in the population, and they increase they act as comorbidities, that is, they increase the risk of death for these policyholders. Usually a higher premium is charged. And for cases like very high stages of cancer and some of these very life threatening chronic diseases where the lifespan is not expected to be much high, in these cases the insurance company rejects the claim, rejects the selling of the policy. In fact, a lot of times this is what happens. Insurance companies do not sell life insurance policies to people who are suffering from diseases like cancer, which is at a very advanced stage, right? So what happens is, as a reason, because these policyholders go through this underwriting procedure, which may be an underwriting form or it can be a health checkup, some sort of diagnosis, the mortality of the insurance policyholders tends to be lower as compared to the general population for a few years. Okay, so for at least the next few years, or for at least the initial few years after the policy is sold, the mortality is expected to be lower than the general population. Now what does this mean? We are saying for at least at the initial few years after the policy is sold or after where the underwriting procedures have been conducted, the mortality of the policyholders would be lower. The effect of this underwriting might fade away in a couple of years. That is, for example, if I am selling policies to 50-year-olds and I'm not taking anyone with hypertension or diabetes, in a couple of years, let's say in 3 or 4 years, even if they don't have hypertension and diabetes today, the ones I'm onboarding into my life insurance policy, 4 or 5 years from today, 3 or 4 years from today, they might develop diabetes, right? So their mortality at an average over time would become similar to that of the average population, right? But for the first few years where I have specifically selected policy holders who are healthier than the average population, their mortality would be lower. Okay, and this phenomenon is called as temporary initial selection. Let me show it to you graphically. So usually the period for selection can be anything between 2 to 5 years, right? The AM92 table, which we will be using to model selection, assumes a mortality period, a selection period of 2 years. A temporary initial selection period of 2 years is assumed. So what AM92 assumes is that for the first 2 years, right, the mortality of the policy holder is expected to be lower than the average population. So if this is the general population mortality, this is what your select mortality would look like. Okay, select mortality basically means the mortality after selection. For a few initial years it would be very low, and eventually it's higher and it's stable, right? So this is time since policy. Notice that this select mortality is never becoming equal to the population mortality, and actually I've drawn it a bit higher. Let me draw it here. It's never becoming equal to the population mortality even after the end of 2 years of select period. Now I already told you that it should, right? But it does not. Actually, people who have such chronic ailments such as cancer and very severe diseases and all of that, they never take up insurance policies. Very poor people are never able to afford insurance policies who have a higher mortality. So it is observed in general that the population mortality is always higher than the mortality of the people who take up insurance. Okay, so the average mortality of any person who has taken insurance is lower than that of the average population. Okay, that mortality is called as the ultimate mortality, which is this line. Okay, let me draw it with a different color. This is your ultimate mortality. This is lower than the population mortality, and after the select period ends, which in case of AM92 is 2 years, the select mortality becomes equal to the ultimate mortality. Why? Because the selection period has ended and the effect of underwriting, that I have selected a special few people who would have a specifically lower mortality because they've gone through the procedures of filling up an underwriting form, going through a sort of health diagnosis, so their mortality is lower. That fades away after a certain amount of time and select mortality becomes equal to ultimate mortality. Okay, ultimate mortality is usually any sort of life function or survival function or annuity and assurance function, which we'll be studying eventually, that relates to select mortality is denoted by this symbol. This is select X, where X is the age. Okay, and ultimate mortality is denoted by, which is the usual mortality that we work with, is denoted by X. So the symbols that we have discussed, let's get to those. So the select version of TPX is actually TPX. The select version of TQX is actually equal to TQX with brackets around it. We had S deferred TQX, that will be written like this. PX will be written this way. QX will be written this way. Right. So any select function where there is a temporary initial selection involved, we use this sort of symbol. Okay, so that is how it works. Now let me discuss a few more details about this. Okay, now let me discuss with you what a select mortality table with a 3-year selection period looks like. And I'm only plotting LX. DX can be plotted very similarly, right? So I'm just talking about LX. There is a 3-year selection period. Okay, so basically the effect of selection, the effect of the initial underwriting procedures on lowering the mortality of lives fades away after 3 years, right? Let's just say these are the values for the row which corresponds to x is equal to 20. Okay, so I can say L20 with brackets around it, L select 20 is 9910. Then I can say L 20 minus 1, that is 19, plus 1 is 9908. Then you have L let's just say this is what, 18 plus 2 is equal to 9906, and finally L20 ultimate mortality without any selection, the L corresponds to this is 9902. Now what does this represent? Okay, simply speaking, whatever is inside the bracket denotes the age where the selection occurred or where the policy was bought. Okay, whatever is outside the bracket represents how many years it has been since the policy was bought. Okay, how many years has it been since the policy was bought? Okay, so this L20 denotes the L value for the life which is 20 years old and it has just bought the policy. Okay, it has just, because there is nothing outside the bracket, so outside the bracket there is a 0. Inside, this is a life which has bought the policy at the age of 20 and the current age is also 20. How do I know that? First, it's corresponding to 20. Second, if you want to find the current age, you can just take the thing inside the bracket and outside the bracket and add it. Okay, so all of these lives are aged X. Okay, current age is in all the cases, in all of these cases the age is 20. For all of these the current age is 20, right? 19 plus 1, 18 plus 2 or 20, right? So it's 20, right? This life, the first life, bought the policy at the age of 20 because that's inside the bracket and the current age is also 20. This life bought the policy at the age of 19 and is currently 20. It has been 1 year since the policy was bought. Okay, this life bought the policy at the age of 18. Okay, and it has been 2 years since the policy was bought. The current age is 20. Okay, and this life, we don't care about when the policy was bought. It has been 3 or more years since the policy was bought because the effect of selection has faded, right? So that is how it works. Okay, this is how you interpret it. Now let's see how, in case of this table, would I calculate my probabilities. Okay, let's say I want to calculate 2p, or not even 2, let's just say I just want to calculate p20. Okay, in case of this table, what will p20 be equal to? Okay, p20 usually is equal to L21 by L20, right? That is what it is, number of people alive at age 21 divided by number of people alive at age 20. This is the probability that a person age 20 survives for 1 year. Perfect. Now in this case, what will happen is, next year the person would be age 21. That is correct, right? But what would have been the age when they bought the policy? That is what you have to infer. See, at 20 they have just bought the policy, right? Because whatever is inside the bracket is the age when they have just bought the policy, right? So the current age is the age where they have bought the policy. So they bought the policy at age 20. Okay, next year they'll be 21, but they would have bought the policy at age 20. So what will it be? It will be L20 plus 1 divided by L20, right? In the denominator you get the current L, which is 20, and they've just bought the policy, and next year it will be L21, so that what is inside the bracket plus outside the bracket, and 20 is in the bracket because they bought the policy at 20, right? So this is how you can calculate P20. Let's say I want to calculate Q, let's say 3Q 21. Okay, let's say this is what I want to calculate. So it will be equal to L 21, they've just bought the policy, right, plus 3, right? So 21 minus L 21 plus 3 divided by L21, right? Do you understand what I've done here? I have actually written what is the number of deaths that occur between ages 21 to 24, that is the difference of these two, divided by what is the number of lives which are currently alive. This is the probability that a life age 21 will die within the next 3 years, right? So this is how we calculate it. Now, but the point is 21 plus 3 is not a defined symbol here, right? It's just Lx plus 2 plus 2, right? Whenever 3 years will elapse, this indicates that 3 years have elapsed since the policy was bought, right? If 3 years have elapsed since the policy was bought, okay, then what happens? Then basically the selection gets over and the mortality becomes ultimate. So this just becomes L24. Okay, so L21 minus L24 divided by L21. Okay, so this is how you can calculate it. The progression of a life in case of a select mortality table is diagonal. Okay, if a life is currently here, they are at L20. Okay, next year they will be here L21 plus L20 plus 1, because what is this 21 minus 1 is 20 plus 1, so they'll be here. So let's say this value is 9900. Okay, let's just say that this value is this 9900, right? So how will I calculate P20? This is how I calculated it, L20 plus 1 divided by L20, right? Usually the progression in a normal mortality table is downward, but in case of a select mortality table, the life moves diagonally, right? So first it will move to L20 plus 1 because the policy was bought at the age of 20 and it's been 1 year. The current age is 21. Then next it will move diagonally L20 plus 2, and then finally it will get to L23, and then it will start moving vertically because the next one will be L24. And now the selection period is over, so it doesn't matter, right? So this is how it works, right? You would have understood this somewhat, I'm sure, but let's just do more questions so that you understand it more clearly. Let me take one more example before we move on. What will be Q 23 plus 1? Okay, so this is the probability that a life currently age 24 dies within the next 1 year, given that they bought the policy at age 23. Okay, they bought the policy at age 23. Okay, and we want the probability that they die within the next 1 year. They are currently age 24, right? Current age is the sum of these two. When they bought the policy is what is inside. The time it has been since the policy was bought is 1 year. Okay, so what does this become? This becomes L23 plus 1 minus L23 plus 2 divided by L23 plus 1. Okay, how did I get this? The number of people alive at the age of 23 plus 1, that is right now. The number of people that will be alive next year, so this is the number of deaths, that is the difference, and divided by L23 plus 1, which is the number of lives which are currently alive. Okay, so this is how you can solve these sort of problems. Let me get into questions. And in a lot of cases, see, initially these will be confusing for you. The Q values will be confusing for you. So what you can do is you can just do it simply 1 minus 3p21, right? And then p21 is straightforward. This is just 1 minus, what will this be? L 21 plus 3 is 24, and after 3 years the selection period would have elapsed. So this is L24 by L21, right? Similarly, this one would be 1 minus p23 plus 1. So this is 1 minus L. What will be the age next year? It will be 23 plus 2, right? Because they would have bought the policy still at 23, but it would have been 2 years since then. The current age is 25. This is 23 plus 1. Okay, so this is also how you can calculate it. Okay, so then this would be clear to you, I'm assuming, and once we are clear with this, we can move on to the book questions. Okay, so let's just solve these very simple questions, and they're saying calculate the following probabilities assuming AM92 mortality applies, right? So let's just start with the first one, which says 10p90. Okay, so what will be 10p90? Straight direct definition, L100 by L90, right? That is what you'll get. Now, how do you calculate L100 by L90? You just go to the tables, you open your AM92 tables, and LX values are the first ones which are given. It's page number 74. There is no selection in the first part. So L100 is here, okay, this value, and then you just divide it by L90. Okay, so I am leaving this up to you. I am sure you can do this, right? This will be 95.8476, right, divided by 1658.5545. This will be a very small number, right? So yeah, that's how it works. Okay, let's move on to the next one, which is 5p79 plus 1. Okay, what is the current age of this life? It's 80. We want the probability that it survives for 5 years, right? And the selection was done at the age 79. The underwriting was done at the age of 79. So this will be equal to L 85. Remember, in AM92 table there is only a 2-year selection period, right? So after 2 years of selection, it just becomes ultimate mortality. This will be divided by L79 plus 1. That's it, right? And if I see this, this is 79 plus 1, right? So x minus 1 plus 1, this is where you have to refer, right? And what is x? If I want 79 inside the bracket, it will be 80. So I'll find this value against 80, right? So you'll find this value against 80. This is 80 minus 1 plus 1, that is 79 plus 1. So you'll take this value in the denominator, right? 5176.2224. 5176.2224, right? And in the numerator, it will be L85, right? So L85, you will take the ultimate value, which is 3385.2479. Right? Perfect. That's how it works. So super straightforward. Right? Moving on. Next part. Division you can do on the calculator, right? So that's fine. 2Q70. What will this be? This will be 1 minus 2p70, right? And then you can take 1 minus L72 divided by L70, right? No selection in the numerator. Why? Because the 2-year selection period is over. These two you will find in the tables. L72 will be in the ultimate section, and L70 will be the select mortality, which is the first column. Okay, the first column is the select mortality, right? So yeah, where you'll find L70, again 70 itself, right? So L70, and here is your L72 ultimate, right? So this is how you do it. Next one is 5 deferred Q60. Now you can directly apply the formula, okay, or you can divide it into the survival probability and do it then, right? So if you divide it into survival probability, it will be 5p60 multiplied with death within 1 year, so Q65, right? And these two you can solve, right? So this will be L65 divided by L60 select, right? 65 won't be select because the selection period would be over, multiplied with 1 minus L66 divided by L65, right? So this is how you can do it. And the last one is straightforward. I'm leaving it up to you. It's very similar to what we did in the fourth part. So you can do it and check your answer, right? So now you know how to get the values from AM92 as well, right? So that's it. Let's move on.